Sunlight falls on a sheet of glass on a rooftop. Nothing moves, nothing spins. There are no gears, no fuel, and no flame. And yet, somewhere just below that quiet surface, electricity is quietly being born. Light goes in, power comes out. No moving parts at all. Today we slice open a solar panel and follow a single ray of sunlight as it becomes the current that runs your home. Let us cut the panel in half and look at it from the edge. From the top down, the layers stack like a very thin sandwich. First, a sheet of tempered glass, tough and clear. Below it, a film that stops light from bouncing away. Then the heart of the whole thing, 2 wafer-thin slices of silicon pressed together. Under that, a metal backing and a frame. The magic is not the glass, it is the silicon and the invisible border hidden inside it. Think of sunlight not as a smooth beam, but as a storm of tiny packets. Each packet is called a photon. Trillions of them rain down on every panel each second, far too many to ever count. Most simply warm the surface, like sun on your skin. But some carry just the right amount of energy. Those are the ones that matter. When one of them dives into the silicon, the real story begins, and a single electron is about to be set free. So why silicon? Zoom in until you can see the atoms themselves. In pure silicon, every atom links arms with its neighbors, sharing electrons in a tidy, locked grid. Nothing is free to move, so nothing can flow. To wake it up, makers add a whisper of other elements. One side gets atoms with a spare electron to give. The other side gets atoms hungry for one. Same crystal, 2 different moods, now stacked carefully face to face. Where those 2 silicon layers meet, something strange happens entirely on its own. The side with spare electrons leaks a few across the border to the hungry side. But each electron that crosses leaves a positive charge behind it. Soon a tug of war sets in, and the migration stops. What remains is an invisible electric wall right at the seam, a permanent slope of charge. No sunlight yet, no current yet. Just a loaded spring, waiting in the dark for something to trip it. Now let our photon arrive. It plunges through the glass and strikes an atom deep within the silicon. The collision hands over its energy, and an electron, once locked firmly in place, breaks loose. It leaves behind an empty spot, a hole where it used to sit. For a heartbeat, both are free to wander. Left alone, the electron would simply fall back into the hole and the energy would fade to warmth. But this electron has wandered very near that invisible wall. And the wall does its work. That built-in electric field acts like a steep one-way hill. The loose electron is shoved firmly toward one side of the panel, while the hole drifts the other way. They are pulled apart and kept apart. This is the quiet trick at the center of it all. The junction sorts the charges, sending electrons in one direction only. Multiply this by trillions of photons, and one face of the silicon grows crowded with electrons, all eager to leave. All those gathered electrons now need a road out. Look at the front of a panel, and you will see thin silver lines, like the veins of a leaf. These are printed metal fingers, feeding into thicker bars. They touch the crowded silicon and offer the electrons an exit. The electrons pour into the metal, race along the wires, and the only way back to the waiting holes is the long way around, out through your home, doing useful work on the trip. The current leaving the panel flows in one steady direction. We call that direct current, or DC, but the lights and machines in your home run on alternating current, AC, which flips back and forth many times each second. So the wire first meets a box called an inverter. It rapidly switches the flow, sculpting that one-way trickle into the smooth back-and-forth wave your home expects. From rooftop to wall socket, sunlight has quietly become usable power. Here is the humbling part. Of all the sunlight that hits a typical panel, only about 1/5 becomes electricity. Most photons are too weak or too strong, and their extra energy escapes as plain heat. That is why panels grow warm, and why a hot roof actually lowers their output. Engineers chase every fraction of a percent, layering better coatings and purer crystals. The sun pours down far more than we can capture. We are simply skimming the very top of a flood. One slice of silicon makes only a tiny push, about half a volt. So makers wire many cells together inside one panel, then wire many panels across a roof or a field. Linked in long chains, their small voltages add up into something that can run a house or even a town. The single electron we followed is one of an uncountable crowd, all sorted the same way. All marching out the same door, all powered by nothing but falling light. Let us trace the whole path one last time. A photon of sunlight strikes the silicon and knocks an electron free. The junction's hidden field sorts that electron, pushing it firmly to one side. Silver fingers gather the flood of electrons into a wire. An inverter reshapes the one-way current into the wave your home can use. Light went in, power came out, and every single step happened silently, inside a sheet of glass thinner than your thumb. No fuel, no flame, no moving parts, just a quiet slab of silicon, turning falling light into living current all day, every clear day. Next time you pass a roof lined with dark glass, you will know the small miracle humming silently inside. Thanks for slicing it open with us. If you want to see how another everyday system works, stay close. This has been The Cutaway.